graphing the transformations of a quadratic function. They will always be in vertex form like this, and we have to figure out how to get it on this graph, right shape in the right place. I want you guys to tell me what you remember from yesterday on graphing, not yesterday, the past, on how do we graph quadratic functions. What's your first step? Or what did we do in class?
Write out that table.
So Lauren's remembering there was a table of points or values of just your general, like standard quadratic function. So I'm going to put that here. Lauren, do you remember what those numbers were? Or can you think about if we are doing y equals x squared, what would be our table of values?
Well, I have it here. Is that
Okay.
cheating?
So no, please tell me, what do you have?
Okay, so -3, 9, -2, 4, -1, 1, 0, 0. Oh, sorry, am I going too fast?
No, it's fine. You're all good.
1, 1, 2, 4, 3, 9.
Perfect. Does anybody remember where those numbers came from? Like these aren't just a random set of numbers. Where did they come from?
Isn't it like the original like quadratic?
Yeah, good, Makai. So our most basic quadratic equation is y equals x squared. So you take the input, square it, that gives you the output. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. I'm going to graph that first. It gives us just something to look at as far as our when we stretch and or compress this next graph, we can compare it to this shape.
I have a question.
Yes, Makai.
On the test, will we be given that table or do we have to memorize?
You don't have to memorize it. So what I was just saying to Lauren is you will have a memory sheet for this test. I've already put some things on it, Makai, but if you use that table for graphing, I want you to add it.
Okay.
If you don't use it, don't worry about adding it. But I do want each of you to add the steps for how you're going to graph onto your memory sheet.
Okay, and also the other table with like the direction of opening and all that stuff.
Like this transformation chart.
Yeah.
I will have that on the test for you to fill out. And actually, I have that on your memory sheet. Makai, remind me, I'll show you your memory sheet when I'm done these 2 questions.
Okay, thank you.
Yeah, but I did not have a section on graphing because each of us are kind of figuring out our own way of graphing. And so I want you to put your own note on how to graph and what steps you're taking to graph. Now that I have this basic equation, which is actually not the quadratic function that I'm trying to graph, what will I do to make this blue graph look like the actual quadratic equation given? What will I do next?
You have to fill out the other chart.
And what am I going to do to fill that out, Makai?
You're going to put in like the direction of opening.
Oh, I'm not going to worry about the transformation chart yet. You could do that, but I'm just trying to graph it right now. So if I look at my blue graph, which is y equals x squared, how am I going to get it to look like this equation? What's the next thing I'm going to do?
You can put the vertex.
I'll do vertex last. I really want to get it to have the right shape first. So which letter or what number in this equation is my shape?
The -2.
Good. I'm going to first deal with the A, then I'll do H and K. So do this actually in the order of your equation. So what I'm going to do with the A value is I'm going to take my table of values and I'm going to multiply it by -2. All of my Y values are going to get affected. -8, -2, 0, -2, -8, -18. And now all of my points will be now -3 is going to go to -18. -2 will be down at -8, -1, -2. So now I'm changing all of my points. I can't get negative 18 on this graph, but I can do negative 2, negative 8, negative 1, negative 2, 0, 0 still there, 1, negative 2, 2, negative 8. So let's just kind of think about, does this look like it makes sense? If my A value is a negative 2, oh man, I'm having a hard time writing on my screen. If my A value is a negative 2, which direction should it be opening?
Down.
Down. I'm actually going to fill that in right now. And should it be stretched or compressed?
Stretched because 2 is greater than 1.
Perfect. So all of my Y values actually doubled, stretching this parabola, and it's also opening down. So check and check. That makes sense. Now I'm going to worry about my vertex. What are the coordinates of my vertex?
Is it +5 +2? I mean 1.
Good, +5 and 1. Actually, I'll fill that in here while we're talking. 5 and 1. Okay. What I need to do is move this parabola over to here. I need to get that red parabola shifted over there. What options do I have?
You can like count each point over, like what, yeah, I don't remember what it's called. Or you can do the other one, which is like, I don't know, one of them you like shift it over and then
Yep.
the other one just start at the vertex and like do it again.
Yeah, so if I look at where my red vertex was at 0, 0, I shifted it right 5 up 1. So you could take every point and go right 5. So 1, 2, 3, 4, 5 up 1. 1, 2, 3, 4, 5 up 1. 1, 2, 3, 4, 5 up 1. And 1, 2, 3, 4, 5 up 1. And this would be my new parabola. Okay, so you could move every point over and up if that's the method you choose. Or Lauren said there was something about just looking at the vertex and shifting this shape over. So if I was going to use it by translating it over here to this vertex, from the red vertex, I went over 1, both directions from the vertex, and down 2. So I went over 1 and down 2 to get to those points. So now I'm going to go over 1 from my vertex, each direction, down 2. These points were over 2, down 8. So I can also follow that same pattern here, over 2 and down 8. Either method will get you the exact same parabola. All right, so we have the green one is my final graph. And it looks good. It's opening down, it's stretched, and the vertex is at 5 and 1. So that's great. So let's fill in the rest of this chart. We already said it's opening down. That was looking at my A value. Stretch or compression is also my A value. The vertex we have is H and K. We have all this. What's my axis of symmetry?
X equals 5.
Very good. So X equals H is the general equation. And what about domain and range? What's your domain? What's your range?
Domain is open bracket XER.
Good. And for all of our quadratic functions, that's the same. And what about range?
It's open bracket YER line, and then I don't remember which way the thing goes. Let me check. It goes like I don't know how to explain it. It's like facing the open part is like facing. Yep. Yep. Yep.
I I'm reading your mind. I have the power to read minds now, Lauren.
Yeah, and then it minus, I can't remember what the value was. What was it again?
It's your K value.
3 minus 3? No, minus
Uh,
1.
One.
1.
One. Good, good. Awesome.
Oh,
Alright.
that was painful.
And Lauren, can you explain why you picked less than here for range?
Yeah. Because like a while ago we wrote like if it's a smiley face, then it goes the other way, and if it's a frowny face,
Yes.
it goes that way.
Good. This one is opening down, so it has a maximum value. So that means that this parabola, the highest it goes is 1. So y is equal to 1 and everything less than 1 because it's opening down. So literally everything about this parabola is on this page. You've got the graph, you've got everything described about the properties of that quadratic function. Awesome. Questions on this one?
I just had a question.
Mhm.
For every time we are talking about the compression factor, do we have to say like what it's by, like stretched by whatever?
No,
Do we use marks?
you could just do stretched or compressed. I put the 2 there because I like to see, does it kind of look like that on my graph, and I can compare all the data, Alexa, but just put either stretched or compressed is fine.
Okay.
But I don't want you to put just 2 because I want to know, do you know what happened to the actual shape of the graph? Okay. All right, we're gonna try one. Oh, what happened? Apparently I started with my second problem. Hopefully you guys figured that out. I don't know why that was on slide number 2. Let's try graphing this one. I want you guys to tell me as much as possible. Here is my equation. Y equals 1/2 x plus 4 squared minus 3. What do you want me to do first?
Make the chart again.
Okay. For those of you that are skipping this step, feel free to continue skipping this step. So -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and plot those on your graph. And what is next?
Then you take the A value
Awesome. And Makai, what will I do with the A value?
and then you multiply everything on the chart by that.
Good. So 1/2. If you want to change it to 0.5, feel free. 1/2 of 9 is 4.5. 1/2 of 4 is 2. 1/2 of 1 is 1/2, or 0.5. 1/2 of nothing is nothing. 1/2 of 1 is 1/2. 1/2 of 4 is 2. 1/2 of 9 is 4.5. Okay, and I'm going to graph those. So at -3 on my x value, I'm going to have the point at 4.5. At -2 x value, my point's going to be at +2, so on and so forth. So -3 is now at 4.5. -2 is at 2. 1 is at 1/2. 0 is still at 0. 1 is at 1/2. 2 is at 2. 3 is at 4.5. Okay, I'm just going to stop for a second because I don't want to translate any errors. Based on an A value of 1/2, which direction should it be opening?
Up.
And should it be stretched or compressed?
Compressed.
Okay, does our graph reflect that?
Yeah. No. Yes.
What? Let me go back up here for a second. You guys can see. Does it open up and does it look compressed? Compressed is like it got sat on, it's wide.
Yes.
Yes, okay. Now what?
So you get the vertex.
Okay, good. Where is our vertex?
It'd be -4 and -3.
-4, -3. All right, -4, -3 is here. And just wondering how many of you guys are shifting every point. Hold on 1 second, let me. Okay, so if I'm shifting all of them, you're shifting them all left 4, down 3. It's hard with the halves, so just be really, really careful. So left 4, 1, 2, 3, 4, down 3, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Oh, it gets a little jumbled there. That's okay. Okay, here is shifting all the points. And doing that one more time, just looking at the pattern. Looking at my vertex, I'm going over 1 on each side and just up a half. Going over 1 on each side of my vertex and only up a half. Then I'm going over 2, up 2 from there. So over 2, up 2. Over 3 and up 4.5. Same exact parabola as our final product. Questions on that graph? And then let's just finish up our transformation chart. What is the axis of symmetry?
-4.
Good, x equals -4.
-4.
Yep, good, Alexa. And domain and range.
Range is XRER, like the usual with the squiggly brackets.
Yeah, so domain is, domain is
Oh, I was gonna say
XER.
range.
Yeah, that's okay.
Okay. And then range is YER with like the one squiggly bracket, line Y. And then it's like greater than Y, like it's facing the Y, like it's opening towards the Y. Yeah.
Yeah. And Alexa, why did you pick greater than for this one?
Because it's opening up.
Good. So if I look at my graph, this one has a minimum value. The lowest it dips down here is a Y value of -3, and it's everything bigger than that as it opens up. So it's going to be the greater than symbol.